In this module, we're going to talk about spatial information. We're going to talk about the data that generally have coordinates, and they are located in a specific position in space. So we can begin with the management of spatial information by using the R software and also some demonstrations on the QGIS software. The main tools that we're going to see in the R software include the vector data, like the SF package, also the raster data in the raster package, and also we're going to talk about the spatial and temporal correlation with the SPDEP and GSTAT packages. And finally, we'll start to talk about machine learning, like spatial dependence and how this affects these models. And it can cause adjustments. And this is part of the LR3 package. So these are links for different type of auxiliary material. This is a very broad topic, and you can look for additional information. You can find a lot more things. So this book about data analysis in R is very interesting, and they're in English, but it's very interesting. And this is another book in PDF format, written by a professor that's in Spanish. It's really interesting. It's got a very complete description. And there's some additional introductions, some parts related to the spatial dependence and the correlations. This is an application developed by a postdoc called Agustin, and he already did a video to demonstrate how this tool can be used and understand how the variogram and the characteristics of the maps behave. This one is also part of the first book that we had before, but this is more focused on machine learning and how that spatial correlation has to be understood here. And this last book would be the base of the package and how to use it. So if you have any doubts, you can go to this material, and it's going to be very useful. The main package that we're going to be using in the R software for working with the spatial data, especially the vectorial information that include the points, the polygons, all this stuff. This will be the SF package. SF means simple features, and this is a very simple way to store spatial data, like a column, let's say, that has the geometry. So let's say that I have a table that in QGIS would be the attribute table. That could be what we use on tables, and a special column that has specific characteristics. So this is the format that's being used in R to represent that. So this and many other packages are there. Some of them work differently, but in general terms, these SF is considered as the most modern and updated version to work on. So that's what we're going to be using here. This is part of the function sheet of this package. So I'm going to leave these functions. We're not going to see all of them, but it's just for you to know that there are different functions and what you can do with each one of them. So that's the link if you want to see more information. There's 2 pages with additional functions. So beginning with the vector data. Generally speaking, the type of data that's being used to represent the spatial information would be these 2, vector data and raster data. So the vector data, everything begins with the point. So the base, the foundation, everything is that a point usually has 2 coordinates in 2 dimensions. So you have the x and the y, or the latitude and longitude. That will be the basic unit. And they can be combined in a line that's here. So when they're in a line, they're called diverts. And these points that form a line can also form a polygon that you can see down here. So this closed line has that limitation. Whatever is inside, you can see what's inside the line and outside the line. That would be a polygon. So these are the three main ways it can be used to represent spatial data that come in vector. Then you can combine a line. It could be multiple lines, and this is useful because in order to maintain this unique relationship between one row in the attribute table and geometry, sometimes you have the need to have a geometry that has different parts. So that's why we have these three different formats. We have the multi-line, the multi-polygon, and the multi-point. So right here, you're representing just a point. It could be one point or several points, multiple points. And finally, there's a special type of geometry that will be the collection of geometry collection. This can add any of the others. So it could be a combination of others. And this comes from different operations that are done and that can give you as a result a collection that's heterogeneous. But to store data and to have a general organization, it's preferable to use these homogeneous formats where everything is either a line or a polygon. But this exists because sometimes it's important to have an option. So I'm going to leave another link here so that you can study a little bit more. So this is how you can see the vector data in R with the SF package. So I read one of those data files, and this one has the multi-polygon type. This is data from the limits of the municipalities in the Chiapas state, and they're multi-polygon. They could be polygon, but if there's a part of the municipality that has an island, let's say, or something like that, that's why you need to have the multi-polygon option. And this is a special column for geometry, for multi-polygon, and this is the unit that's in degrees, because this would be longitude and latitude data. So this is a very common thing that you're going to see in R. These are the other columns from the table, and this is the special column that would be the geometry. And if I do a fast map of this column, you'll be able to see that the geometry is what you can see here. These are the polygons. And you're going to choose the other columns that are not geometry to apply a style. So this would be the name of the municipality and the key of the municipality. And there's a random colors, just to give an example. So these are the data. This is the data. Another important point of this SF package and why it's preferable compared to the others that can be used to represent spatial information is that this is compatible with the functions of the deep layer package that we saw before. So for example, in this case, I can use a function from this package that's called stArea to calculate the area of each geometry. And one of the functions of the package deep layer, so we had a range to organize the rows. So I'm going to organize the rows from the data set that's called límites based on the area of each polygon. So this would be the area from each municipality. Even though this information is not here, because I'm not seeing the area, it's not like a column, but it's still information that derives from the geometry that can be calculated. So the results are going to be here organized based on the area. This is another advantage because it allows us to use all of the deep layer functions in a very convenient way. And in the same way, if I want to add the area column in the attribute table, I can use the mutate function, and it includes area. And I have also square meters, and these are the values. Everything that can be computed with the geometry can be done by using the functions of the deep layer package. It's very convenient. And this will be the map of the area column that I just added. And this is the municipality that has a very large area. The others over here have smaller areas. And this is the color scale. So this is another way to do the calculations and prepare some maps with information from the spatial information.